Hello everyone, welcome back to the another session in design and analysis of algorithms. We'll be going to talk about multi-stage graph. You can find this topic in third unit. Today we'll be going to talk about three different things from this video. The one is what is multi-stage graph, how dynamic programming is applicable on this graph, and how to solve multi-stage graph problem using forward method. These are three different things what we are going to cover as part of this video. Now let's understand what is multi-stage graph. We already come across with what is graph in the previous videos. Now what is a graph? Graph G is equal to V comma E. So V is number of vertices, E is pair of edges. So multi-stage graph is said to be a graph, and it is a directed graph, and it is also a weighted graph, in which the vertices are partitioned into k greater than or equal to 2 disjoint sets of Vi, where I lies in between 1 to k. In addition, if u comma v is an edge in E, then u belongs to Vi, v belongs to Vi plus 1 for some I 1 less than or equal to I less than k. We'll take an example to show how these two definitions reflects in the graph. Now this is the example where you can understand what is multi-stage graph. The first feature of multi-stage graph is it is a directed graph. So you can find the directions from one vertex to the other vertex. And it is a weighted graph, that also you can find in the given graph. So this is what edge of the graph, this is what weight of the graph, cost of the edge. And the third is vertices of this graph are partitioned into stage wise. That means three vertex is in V1, V2, V3, V4. Okay. So partition vertex are what? K greater than or equal to 2 in disjoint sets of Vi, where I lies in between 1 to k. That means minimum of 2 stages are required to show it is a multi-stage graph. So here how many stages I have? 4 stages I have. So it is a multi-stage graph. Now u comma v representation in multi-stage graph is what? U is belongs to vertex, V is belongs to Vi plus 1. The next stage, let us suppose, we'll take some example. Take any of the edge. I am taking this edge, 5 comma 2 I am taking. So phi is what? Vertex, correct? This is vertex which is available in V3. It is Vi. 2 is what? It is Vi plus 1. Phi is available at V3. This 2 is available at V4. So this is what UV representation in the multi-stage graph. Now, the first stage and the last stage will have just a single vertex to represent the starting point, that is source, and ending point represents with the sink. So I am denoting with S and T. So source and target or source and sink. This graph is usually useful for representing resource allocation problem. So here there are various parts from source to sink, that you can see 3 to 5 and 5 to 2, 3 to 4, 4 to 5 and 5 to 2, 3 to 4, 4 to 2. So there are various parts from source to sink. But what is the objective of this problem? The objective of the problem is what? We have to select the path which is giving minimum cost. This is what the objective of this problem. So it is a minimization problem, that it is an optimization problem. So as it is an optimization problem, I can apply dynamic programming over here. Dynamic programming. Now dynamic programming works on one principle, which is optimality principle. So what is optimality principle? It says that a problem must be solved in sequence of decisions. Let's understand with an example how dynamic programming is applicable on multi-stage graph. Now, before we see the example, we should know how minimum cost will be calculated, right? It is very important to denote it in a formalized way. So the multi-stage graph problem is to find a minimum cost from path from S to T. S is what? Your source. T is what? Sink. Each set Vi defines a stage in the graph because of the constraints on E. Every path from S to T starts in stage 1, goes to stage 2, then it to stage 3, then it to stage 4, and so on till stage K. So minimum cost will get calculated by moving from stage 1 to the other stage. So this is what the procedure to find out the cost. But we should know how to find the cost, right? So we'll write one formula how to find the cost of our graph. So finding the cost of a graph is what? Let's see. I wanted to find the cost of I comma j. Okay. So cost of I comma j, as I did not have a single vertex to reach S to T, as I need to travel from other vertex 2, so always cost will be what? It is better if you can have a single path from source to T. But most of the cases we don't have single path. If you have to reach from S to T, if you have the other paths too, the cost has to be calculated through other paths. And there are third case is what? You can also have the other paths and where it can also have minimum and maximum cost to reach your T. So keeping in mind all the possibilities, we have a formula to calculate cost of it. So when you have all these paths, we will not take all the paths. We'll take only minimum cost. So that's what? Minimum of C of j comma L plus cost I plus 1 comma L. So I'll write in other slide the cost of I comma j is equal to minimum of C of j comma L plus cost of I plus 1 comma L, where j comma L belongs to edges and L belongs to Vi plus 1. This is the formula to calculate cost of the edge. You can take any example from this graph. So I am taking the example of some cost 6 comma 9 I am taking the example. 3 comma 6 I am taking the example. Cost 3 comma 6. What is 3 stage? This is what you have to always keep in mind. 3 is what? Stage. J is what? Vertex. This is what? Vertex. Now, how to calculate cost 3 comma 6? Now let's see where we have a third stage. Represent the stages V1, V2, V3, V4, V5. So go to stage 3 where it is. This is stage 3. In stage 3, vertex is what? 6 vertex. Vertex is 6. Now in stage 3 vertex 6, to find the cost of it, you have to find first of all minimum of C 6 comma 9. What is this C? Say C j comma L. J and L both are belongs to edge. Edge means this 6 comma 9 cost we need. Okay, and after you know C 6 comma 9, you have to add this value to the value which is cost 4 comma 9. That means cost 4 comma 9 is what? 4 is stage number 4. That's what L represents what? Vi plus 1. Stage number 4, vertex 9. What is the cost of this? So once you know this, then it will be easy for you to calculate the cost. So we'll solve this problem. That means we'll find the cost of this multi-stage graph, but keep this formula in the mind. Now let's get started with the same. So first of all, we have to start from the source to target or source to sink. Now, the thing is over here, I'm not moving from source to target, but I'm coming from target to source. Because to reach from source to target, I have to take other nodes also. But if I come from back to front, that means target to this, then it will be very feasible for us to know what is the defined cost. Here it is the cost of the other edge is what? Always it will be infinite as we are not aware of it. But when you come across this node, then you will be very sure that what is the cost of it. So better always to move from last to the sink to the source. It doesn't mean that I am changing the direction. No, I am not changing the direction. This edge always shows that you are traveling from 9 to 12. But when you are making this point from 12 you are moving, then it is defined cost. 4 is a defined cost. So we are moving from what? Cost 5 comma 12. What is this 5 represents? 5 represents stage number. 12 represents vertex which is available in the stage. So these are the stages: V1, V2, V3, V4, V5. So in cost 5 comma 12 is what? It is 0. Correct? So I am representing. For this reason I have taken table. Now D is what? The vertex value. The vertex which give this value, you have to make note of this. Now move from 12. To 12, which vertices are there? From 9 is having a direction, 10 is having a path, 11 is also having a path. So now calculate the cost of 9. 9 is available at which vertex? 4 vertex. That means 4 comma 9. So what is the 4 comma 9 value? 4. 4 comma 9 value is 4. The same way, cost 4th stage only, but I have other vertex which is 10. 4 comma 10 value is 2. This value. I am writing this value. And the next is cost of 4th stage, 11th vertex, which the value is 5. Now put the same values in the table. Next time whenever you want these values, you need not to calculate. Better you take from the table. That is the reason I am taking tabulation method. So cost 4 comma 9 you update here. 9 vertex value is what? 4. We'll take other ink. 4 and 10 vertex value is what? 2. 11 vertex value is what? 5. So to reach which vertex? 12. So I am updating 12. Now again move to third stage. Third stage. What is there in the third stage? Cost 3 comma 6. 3 represents stage number. 6 represents vertex number. 3 comma 6 is equal to, we have to choose the minimum value, because from 6 vertex there are two paths which are going. 6 to 9 is 1, 6 to 10 is 1. So among these two, which is minimum, we have to calculate. That's what I am taking minimum of C of 6 comma 9 plus cost of 4 comma 9 comma C 6 comma 10 plus cost of 4 comma 10. Now what is the value of 6 comma 9? C of 6 comma 9. That means C represents the edge of this. 6 comma 9 is the edge. J comma L belongs to edge. 6 comma 9 value is what? 6. Now take this 6 plus cost 4 comma 9. Cost 4 comma 9 value is what? 4 represents the stage, but the cost of 9 is what? 4. Now take the 6 plus 4. Now C 6 comma 10 is what? C 6 comma 10 is what? 5. Now take this 5. Cost 4 comma 10. 4 is stage number, but the cost of 10 vertex is what? 2. Take this 2. That means minimum of 6 plus 4 is 10 comma 5 plus 2 is 7. So minimum of 10 comma 7 is what? 7. So which value you calculated? 6 vertex value. This 3 represents stage number. This 6 represents vertex number. Cost of 6 vertex is what? 7. Cost of 6 vertex, here it is 7. So which value from which vertex you got this value? 7 is representing what? 10 vertex. So write over here 10. Now again move to third stage. 6 vertex is finished. Now third stage, 7th vertex is there. Now again calculate cost of 3 comma 7. 3 represents stage number. 7 represents vertex number. 3 comma 7 is equal to minimum of, again 3 comma 7. Come to 7. 7 is having 7 to 9 you have path. 7 to 10 also you have path. So now you have to take either this value or this value depending upon the minimum. So that's the reason I am taking C7 comma 9 plus cost 4 comma 9 comma C7 comma 10 plus cost 4 comma 10. Now what is the value of C7 comma 9? C7 comma 9 edge value is what? C7 comma 9 edge value is 4. Now take that 4. Cost 4 comma 9 value is what? 4. Cost 4 comma 9. 9 value is 4. Now C7 comma 10 value is what? 3. Cost 4 comma 10 value is what? 10th vertex value is what? 2. Now 4 plus 4 is 8 comma 3 plus 2 is 5. So which is minimum? 5 is minimum. Which vertex given this value? 5. 10th vertex is given the value. Correct? So update this. You have to update in the 7th vertex. 7th vertex value is 5 you got. 7th vertex value you got as 5. Which vertex given the value? 10th vertex is given the value. So you have to update like this. We are at this vertex and again you have to calculate this stage. So this stage is what? Cost. Now again calculate cost 3 comma 8. This vertex is 8. Stage is 3. That means you have to calculate cost 3 comma 8. So if you calculate cost 3 comma 8, then what is the formula? Again calculate cost 3 comma 8. Cost 3 comma 8. So if you calculate cost 3 comma 8, now that means you are at this vertex. How many paths you have? 8 to 10 is 1, 8 to 11 is 1. So take that minimum because you have two possibilities to choose. C8 comma 10 plus cost of 4 comma 10 comma C8 comma 11 plus cost of 4 comma 11. Now minimum is equal to 8 comma 10 value is 5. Now write 5. 5 plus cost 4 comma 10 value is what? 2. 5 plus 2 is 7. And this value is what? 6 plus 5. So now minimum is what? 7. Which vertex is given the minimum value? 10th vertex is given the value. So update your table. In the previous already we got 6, right? 6 value is what we got in the previous slide. 7, 10, 5, 10, 7, 10 and 4, 12, 2, 12, 5, 12, 0, 12. Now in the same way you have to calculate 1, 2, 3, 4, 5. Right? So you calculate it, you will get this cost as 16, 7, 9, 18, 15 and 8 vertex, 6 vertex, 7 vertex and this is 2 or 3 vertex. Apply the same thing, you will get stage 2 and stage 1 values. Right? Apply the same formula, you will get. Now, where we have taken sequence of decisions? No, we were not taken sequence of decisions yet. We were just calculated the cost of the matrix. That's it. Now you have to take sequence of decisions. The sequence of decision is what? Whether you have to travel from this vertex. You have two possibilities here. The one is what? Choosing of 2. The other one is choosing of 3. Now let's see what the minimum path we got from this tabulation method. That what we got is two vertex starting from 1 to 2. This we got 1 to 2 and 2 to 7, 7 to 10 and 10 to 12. This is one path we got, correct? And the other path also we got 1 to 3 and 3 to 7 and 7 to 10 to 12. This is also one of the path what we got. So how I know that I got this, correct? So as I have seen the d values, I given direct figures, but let's see. I'll give more clarity the way how I have chosen this path. From the d values, that's the reason why we mark this d values. Now look at this. Now d1 comma 1. So d1 comma 1 is what? We are moving, 1 is what? Stage. 1 is what? This vertex. This one is stage, this one is vertex. So d1 comma 1, where I am going, I am just choosing the path which is minimum, and that is what? 2 I am taking, because you come here you will be knowing d1 comma 1, d1, what you have, 2 you have, 3 you have. So I am taking the value of d1 comma 1, which is either 2 I can take or 3 I can take. So I am taking this 2 first of all. I am taking this 2. Now d2 comma 2, stage number 2, 2 vertex. Stage number 2, come to vertex 2. In vertex 2, what the value of d value? 7. Now the same, d3 comma 7, stage number 3, vertex number 7. d3 comma 7 is what? d3 comma 7, stage number 3, vertex number 7, this. So the value is what? 10. And d4 comma 10, the value is what? 12. So this is one path. The one path is what? 2, 7, 10, 12 is one path. According to this tabulation method, according to the vertex which given the shortest path, that is what? This 2, 7, 10, 12 is one path. The other path is what? The other path is, again write down the other path. So the other path is d1 comma 1, I am just changing 3. Go to 3, first stage, first vertex value is 3. Choose this 3. Now go to this vertex 3. d2 comma 3, where is 3 available? The vertex 3 is available at second stage. Go to this 3. 3 is having which? 6. Now come to 6. 6 is having what? 10. So now d vertex 3, stage number 3, 6. The value is 10. Now come to this 10. 10 is having what? 12. So d4 comma 10, which is 12. So this is other path. 3, 6, 10, 12 is other path. So that's what I have represented. Looking at the direct values, that's what I have given the clarification also. The reason why I taken this 2. So 1 comma 2 is the 1 comma 2, 2 to 7, 7 to 10, 10 to 12 is one path. 1 to 3, 3 to 7, 7 to 10, 3 to 6, 3 to 6, 3 to 6, 6 to 10, 10 to 12 is the other path. These are what? 2 paths what we were got minimum cost of from this multi-stage graph. Now the point is what? We were not taken any sequence of decisions yet. You have to take a sequence of decisions, right? What is sequence of decisions? To travel via 2, 7, 10, 12 or to travel 3, 6, 10, 12. So you have to take a decision on which path I have to travel. Based on the data available, we started from the vertex 1 to sync using forward method. So this is what the way of taking decisions using dynamic program to solve a multi-stage graph problem. Thank you all.